It's hard to wrap your head around the scale of the universe. We live on this little planet, orbiting a medium-sized star, and to us it feels like everything. The sun, the moon, the planets we've learnt about since childhood. They form the boundaries of what we think of as our sky, but when you step outside on a clear night and look up, what you're really seeing is just the tiniest fraction of what's out there. Every single star you see is its own sun. Many of those suns are surrounded by their own planets, their own moons, their own belts of asteroids and comets. There are billions of these systems in the Milky Way alone, and the Milky Way is just one galaxy among billions more. For most of human history, that was just an idea, not something you could see or prove. Our solar system felt closed like an island. Sure, comets came and went, but they all belonged to the same family, tied to the sun's gravity. That sense of isolation was broken only recently, within the last decade, first in 2017, when astronomers spotted a strange object named Oumuamua, a long, thin shard of rock that came out of nowhere and left just as suddenly, on a path that meant it could never have been ours. Then, in 2019, another visitor arrived, Borisov, a comet glowing with a proper tail, the first clear sign of an icy wanderer from another star. And in 2025 it happened again, on July 1, in the mountains of northern Chile. A telescope caught sight of something faint, something moving, that turned out to be only the third interstellar object humanity has ever seen. That telescope belongs to NASA's ATLAS survey, the Asteroid Terrestrial Impact Last Alert System. Normally it's busy scanning the sky for asteroids that could get a little too close to Earth. Night after night it takes wide-field images, comparing them, looking for any dots that shift against the background stars. Most of the time the results are routine, small asteroids, familiar comets, satellites drifting past. But on that July night, the data showed something that didn't fit neatly into the usual categories. A faint moving point, given a temporary code, R1MPLAP3Z. Nothing special at first glance, just another detection, one of thousands. But when astronomers began calculating its orbit, they realized this wasn't ordinary at all. The path didn't close. It wasn't looping around the sun like everything else in our solar system. Instead, it was wide open, a hyperbolic trajectory with an eccentricity of around 6. That number alone was enough to cause a stir. Anything less than 1 means the object is bound to the sun. 1 is a perfect parabola, a borderline case. Anything greater than 1 means it's not from here. 6. That's not even close. That's the unmistakable signature of an object arriving from interstellar space. That's how a faint dot with a clumsy code became 3 Sciatelis, the third interstellar object ever found, named for the telescope that spotted it. Suddenly, this wasn't just another entry in a catalogue, it was a piece of another star system, a fragment of some distant place that just happened to wander into ours. The more astronomers looked, the more interesting it became. Pre-discovery images were found from June 14, 2 weeks before it was officially noticed. Even the Zwicky Transient Facility in California had caught it unknowingly in its nightly scans. Those earlier sightings helped refine its orbit, making the case undeniable. This thing came from beyond the sun's reach. Now here's what makes Atlas stand out from the other interstellar visitors we've seen. Size. Based on its brightness and distance, the nucleus is estimated to be about 10 kilometers across. That's huge compared to its predecessors. Oumuamua was no bigger than a city skyscraper, maybe a few hundred meters long at most. Borisov was bigger, about 1 kilometer wide. Atlas, though, is more like a mountain, closer in size to Everest than to anything you'd call a rock. To survive billions of years drifting through space, enduring collisions and cosmic radiation, you need to be sturdy. Atlas is that, a survivor, large and stable, a solid body that's held itself together while countless smaller objects were destroyed. And unlike Oumuamua, which baffled everyone by refusing to behave like a comet, Atlas is clearly cometary. Right from the start, a coma was visible, a hazy cloud of gas and dust around its nucleus, created as frozen materials warmed and sublimated. Over the weeks after discovery, the coma thickened a little and a tail appeared. At its longest, the tail stretched about 25,000 kilometers. For perspective, that's twice Earth's diameter. Not massive by the standards of our solar system's great comets, but far from nothing compared to Oumuamua, which showed no activity at all. Atlas was lively compared to Borisov, which was explosively active. Atlas was more restrained. It sits in between, quiet but undeniably alive. Its color is another clue. Observations show a reddish tint, similar to the outer solar system bodies we know. Kuiper belt objects, Trojan asteroids, even some of Saturn's moons. That red comes from radiation chemistry. Over billions of years, cosmic rays strike icy surfaces, breaking apart molecules and reassembling them into complex organic compounds that stain the surface. The longer an object spends exposed, the redder and darker it becomes. Atlas's reddish face is a marker of its long journey, its enormous age. Even its spin has been measured. By watching how its brightness fluctuates over time, astronomers determined that it rotates once about every 29 hours. That's a slow, steady spin. It means it's not tumbling wildly like some comets do, and it's not spinning so fast that it risks breaking apart. It's stable, calm, almost deliberate in its rhythm. For something that's been wandering the galaxy for billions of years, that kind of quiet steadiness feels appropriate. As for its path through our solar system, that's been charted with precision. Atlas will make its closest approach to the Sun on October 30, 2025, at about 1.4 astronomical units, just inside the orbit of Mars. The closest it will come to Earth is about 1.6 AU, or 240 million kilometers. That's safe. It won't come anywhere near us. No fiery collision, no dramatic close pass, just a distant visitor, quietly sliding through. After perihelion, it will fade, vanishing from our view. Its orbit is a one-time pass. There is no return. Once it leaves, it will keep going, carrying its reddish dust and ancient ice back into the galaxy on a line that stretches toward infinity. Its origin can't be pinpointed. Too much time, too much distance has erased its trail. All we know is that it came from somewhere else, and it will end up somewhere else again. That's what makes Atlas so extraordinary. It's not just a comet, it's a message in a bottle from another star system, drifting into ours by chance. We may never know which star it came from, what planets circled nearby, or what other fragments were scattered alongside it, but we do know this. It is older than Earth. It has been traveling longer than our sun has been shining, and for a brief moment in the middle of 2025 we get to see it. The universe is full of mysteries, many of which we can only begin to comprehend. But what makes the discovery of Thrian Atlas so special is that it brings with it a tangible piece of that mystery. Unlike the stars that adorn our sky or the comets that have long been part of our solar system, Atlas is something completely different, a wanderer from beyond, a relic of another star system, a traveler through the vast cosmic void. At first glance, 3IO Atlas may appear to be just another comet, a faint streak of light trailing behind it as it moves through the sky. But when you dig deeper, you realize that Atlas is far more than just a comet. It's a survivor, a solid body that has managed to withstand billions of years of cosmic travel, collisions, and the harsh conditions of interstellar space. Let's start with its size. While other interstellar visitors have been relatively small, objects like Oumuamua, which could fit comfortably within the confines of a skyscraper, Atlas is something altogether more imposing. Estimated to be about 10 kilometers wide, it's more akin to a mountain than a space rock. Imagine Everest, but floating through the void undisturbed by time and space. Its size alone is a sign that Atlas isn't your average comet. It's not fragile like smaller objects. It's robust, stable, and has withstood the test of billions of years. Such endurance is remarkable, especially when you consider the countless small objects that have been obliterated by Iosic forces along the way. But it's not just the size of Atlas that sets it apart, it's the way it behaves. Most comets, when they approach the Sun, begin to shed gas and dust, forming a coma, a hazy cloud that surrounds the nucleus. But what makes Atlas so intriguing is that it was a comet with a clear tail, visible even as it moved through the vast reaches of space. Its tail stretched to an impressive 25,000 kilometers, twice the diameter of Earth, a reminder that Atlas wasn't just a quiet traveler, but a dynamic object, releasing gases and particles as it approached the Sun. Unlike its predecessors, Atlas exhibited a controlled, steady release of material. Compared to Oumuamua, which showed no signs of activity, Atlas was unmistakably alive, its coma thickening and its tail forming as it warmed. Yet, Atlas wasn't as violently active as Borisov, which erupted with far more dramatic outbursts. Instead, Atlas sits somewhere in the middle, a comet that is quietly releasing gas and dust, but without the explosive behavior that some other interstellar objects exhibit. Atlas's reddish hue is another critical aspect of its character. This red tint isn't just a matter of appearance. It tells a story. The color comes from the effects of cosmic radiation, which has been striking its icy surface for billions of years, breaking apart molecules and reassembling them into complex organic compounds. Over time, the surface has grown darker, marking its long journey across the cosmos. The red color is a mark of Atlas's age, a signal that this object has been exposed to the harsh realities of space for longer than any of us can imagine. But there's more to Atlas than just its size, tail, and color. Scientists have carefully tracked the rotation of the object. By measuring how the light from Atlas fluctuated over time, they determined that it spins once every 29 hours. This slow, steady spin suggests that Atlas isn't tumbling wildly through space like many other comets do. It's stable, deliberate, almost as if it's in perfect rhythm with the universe around it. For something that's been wandering the galaxy for billions of years, that steady spin feels almost poetic, a dance that has lasted eons, seemingly unaffected by the forces of the cosmos. What makes this spin particularly remarkable is its stability. It's neither too fast nor too slow, and unlike some comets that risk breaking apart under their own speed, Atlas has maintained its integrity. This stable rotation reinforces the idea that Atlas is a survivor, a cosmic wanderer that has weathered countless challenges. For astronomers, studying this spin is a way to understand not just the physical properties of Atlas, but the broader dynamics of objects that come from the depths of space. The other fascinating characteristic of Atlas is its origin. Where did it come from? What star system did it emerge from? We may never know. The object's path is a one-way trajectory, and the distance it has traveled has erased much of its trail. However, scientists are working tirelessly to study its composition and structure, attempting to unravel the mysteries of its journey. The comet is a window into another star system, and it carries with it information about the kinds of objects that exist far beyond our solar system. Atlas is not the first object to come from another star system, but it is certainly one of the most intriguing. With its large size, its active tail, and its reddish surface, Atlas has become a symbol of what's possible when we push beyond the familiar confines of our solar system. It reminds us that the universe is filled with things we can't see, can't touch, and can't even imagine. But that doesn't mean they're not out there. As we continue to study 3I Atlas, we gain more than just knowledge about one comet. We gain a deeper understanding of the universe beyond our solar system, a glimpse into the vastness that lies beyond the stars we know. In many ways, Atlas is a messenger from the unknown, carrying secrets from distant places, reminding us that there's much more to discover just beyond our reach. The discovery of 3I Atlas did more than just captivate astronomers. It opened a door to a deeper understanding of the universe. Interstellar objects, like Atlas, are not just random visitors, they're cosmic messengers, offering us clues about distant star systems, the conditions under which they formed, and how the universe has evolved. By studying Atlas, we can better understand the behavior of objects that exist far beyond the gravitational reach of our Sun, helping us unlock the mysteries of space itself. What makes Atlas so significant isn't just its size or its cometary features, but what it represents. Atlas is a rare glimpse into the space between the stars. It's a reminder that the universe is vast and interconnected, and that we're not as isolated in our solar system as we might once have thought. For years, we've focused on the solar system, studying its planets, moons, and comets, assuming that everything we needed to know about the cosmos could be found within our own neighborhood. But Atlas has shown us that there is much more out there, objects that travel freely between the stars, carrying with them the story of their origins. Before the discovery of Atlas, objects from other star systems were theoretical. We speculated about the possibility of interstellar visitors, but no one had concrete proof. Then came Oumuamua in 2017, a mysterious cigar-shaped object that entered our solar system from interstellar space. It baffled scientists with its unusual shape, speed, and behavior, leading to all sorts of hypotheses. Was it a comet, a fragment of an alien spacecraft, or something entirely different? That object sparked a new interest in interstellar objects and opened the door for further investigation. Borisov, a more typical comet, followed soon after, solidifying the reality that these objects weren't just theoretical, they were real, and they were passing through our solar system. But it was Atlas that truly expanded our understanding of interstellar objects. Atlas is different because of its size and the way it behaves. While Oumuamua's strange shape and rapid movement made it an enigma, Atlas fits neatly into the category of comets. Its coma tail and steady rotation confirm that it's a familiar type of object, even though it comes from another star system. By studying its composition, behavior, and trajectory, scientists can gain valuable insights into the nature of other interstellar comets, some of which might be even larger or more complex than Atlas. One of the most significant impacts of studying Atlas is the knowledge it provides about the conditions in other star systems. Every object we observe carries with it the story of where it came from, and Atlas is no exception. The reddish tint of its surface suggests that it has spent a long time in space, exposed to the harsh radiation that comes from the stars. The longer an object spends drifting through space, the more its surface is altered by cosmic rays and other forms of radiation. Atlas's reddish color is a signal of its ancient journey, and by studying this phenomenon, we can gain insights into the makeup of other star systems and how objects like Atlas are formed. Moreover, the study of Atlas helps us understand the dynamics of interstellar travel. Atlas's hyperbolic trajectory is a reminder that objects in space don't just follow predictable paths. Their orbits are influenced by the gravitational forces of the stars and planets they encounter. And when an object like Atlas passes through our solar system, it doesn't follow the same rules that govern the planets. The fact that Atlas's orbit is open and unbounded by the sun's gravity reinforces the idea that space is far more fluid and dynamic than we often realize. The discovery of Atlas also raises important questions about the future of space exploration. If objects like Atlas can travel from one star system to another, it's possible that we could one day send spacecraft on similar journeys. Interstellar exploration, once thought to be the stuff of science fiction, is now a real possibility. By studying the paths and trajectories of interstellar objects, scientists can refine their models for how we might one day send probes beyond our own solar system, perhaps even to other stars. Atlas's visit reminds us that we're not just explorers of our own solar system. We are, in time, destined to explore the stars. In addition to its scientific value, Atlas serves as a reminder of the vastness of space. When we look at the night sky, we often think of it as a familiar, somewhat contained expanse. The stars, the planets, the comets, they all seem to belong to us, orbiting within our solar system. But Atlas has shown us that the universe doesn't belong to one star or one solar system. It's a vast, interconnected web of stars, planets, and objects, each with its own story to tell. Every interstellar object that enters our solar system is a piece of that story, a fragment of the larger narrative of the cosmos. And while Atlas's journey may be a one-time event, its impact will be felt for years to come, as we continue to study its composition, its orbit, and the implications of its visit. Atlas also emphasizes how much we still don't know about the universe. Every time an interstellar object passes through our solar system, it raises new questions and challenges our assumptions about space. What other objects are out there? waiting to be discovered? How many more Oumuamua-like objects are wandering through the galaxy unnoticed? And what secrets might they hold about the nature of the universe, the origins of life, and the potential for other civilizations to exist? The arrival of Atlas was not just the discovery of a comet. It was the beginning of a new era in space exploration. It marked the first time that we had a glimpse into the vast unknown regions of space beyond our solar system. And as we continue to study objects like Atlas, we will uncover more mysteries, push the boundaries of what we know, and perhaps one day even unlock the secrets of the stars themselves. The story of Three-Eyed Atlas is one of fleeting encounters, a cosmic wanderer passing through our solar system on a journey that has taken it across unimaginable distances and time spans. Unlike the planets and moons of our solar system, which orbit the sun in predictable, closed paths, Atlas follows an open, hyperbolic trajectory, a path that takes it in and out of our solar system with no intention of returning. Its brief but remarkable passage through our neighborhood raises important questions. How did it end up here? Where did it come from? And what does its trajectory tell us about the nature of the universe? The first thing that stands out about Atlas's journey is its trajectory. It didn't follow a standard orbital path like the planets or the comets that belong to the sun's gravitational grasp. Instead, Atlas entered the solar system on a wide open path. Its orbit was hyperbolic, meaning that it came from a distant star system, passed through the solar system, and will continue on its way, never to return. The fact that its orbit is not closed, the way a comet's or planet's orbit would be, means that Atlas is an interstellar object. Its path is not bound by our sun's gravity, unlike the billions of other objects that call our solar system home. At the time of its discovery in 2025, astronomers calculated that Atlas would pass closest to the sun on October 30, 2025, at a distance of about 1.4 astronomical units, AU, just inside the orbit of Mars. For context, Earth sits at 1 AU from the Sun, and Mars orbits at about 1.5 AU. This means Atlas will make its closest approach to our solar system's central star at a distance roughly the same as the Red Planet, a safe distance by cosmic standards, far from any risk of collision. Atlas's approach to the Sun was carefully monitored by astronomers, who tracked its movement using the most advanced instruments available. By the time it made its closest pass, its course had been mapped with remarkable precision. In fact, scientists knew its position to within a few kilometers, thanks to its trajectory, which was calculated based on pre-discovery images from several observatories, including the Zwicky Transient Facility and the Atlas system. This meticulous tracking of the object's path revealed the stunning reality. Atlas wasn't just a random visitor, it was a cosmic wanderer that had traversed the vastness of space for millions of years, and now it was briefly crossing our path, never to return. Its journey through the solar system was both a marvel and a reminder of the power and unpredictability of space. Atlas had crossed billions of light years of emptiness before it came close enough to the sun for us to detect it. It had passed through regions of space that are beyond our comprehension, zones where stars are born, where black holes lurk, and where the fabric of the universe itself is still a mystery. In many ways, Atlas's passage felt like a chance encounter, an unexpected visitor from a faraway land, a piece of another star system that had wandered into ours by chance. For those studying Atlas, its trajectory also raised fascinating questions about the paths of other interstellar objects. If Atlas had wandered into our solar system, how many more objects like it are out there drifting in the vast cosmic expanse? The fact that Atlas is the third such object we've observed is remarkable, but it also suggests that these interstellar travelers are not as rare as we once thought. In fact, many astronomers believe that interstellar objects pass through our solar system all the time, though we may not always detect them. Atlas's passage provides valuable data about the environment of interstellar space. By tracking its path, scientists can learn more about how objects from other star systems behave when they enter our solar system. The way Atlas's trajectory interacts with the sun's gravitational pull can reveal clues about the conditions in other parts of the galaxy. The more we learn about these interstellar visitors, the more we begin to understand the dynamics of star systems and the space between them. But Atlas's course through our solar system is not just a one-time event. Its path is a reminder of the cosmic forces that shape our universe. The sun's gravity, the gravitational influences of the planets, and the sheer distances between stars all come into play when an interstellar object like Atlas passes through. Studying Atlas helps scientists better understand these forces and how objects move through the galaxy. Every interstellar object that crosses our path teaches us something new about the fabric of the universe. The path of Atlas also reminds us of the fleeting nature of such encounters. Unlike the planets and comets of our solar system, which follow predictable orbits, Atlas's journey is a one-way trip. After its closest approach to the Sun, Atlas will continue on its journey, moving further away from our solar system and back into the emptiness of interstellar space. It will never return. Its journey through our solar system will be brief, but it will leave behind a trail of data and observations that will help astronomers piece together the story of its origins. As Atlas continues on its trajectory, it's important to reflect on how rare and valuable this moment is. For a brief period, we get to observe a piece of another star system, a cosmic wanderer that has traveled across vast distances and time. Its trajectory may be one of randomness, but it has given us a window into a larger universe, one that is far more complex and interconnected than we ever imagined. In many ways, the passage of Atlas reminds us of how much we still don't know about the universe. It's a reminder that space is full of surprises, and even the smallest, faintest objects can reveal profound truths about the cosmos. As we continue to observe its journey and study its path, Atlas serves as a powerful symbol of the mysteries that lie just beyond our reach, waiting for us to discover them. When 3i Kepler completes its brief visit to our solar system, it will continue on its journey through the galaxy, vanishing from view as it follows its path into the vast, dark expanse of interstellar space. Its encounter with us will be a fleeting moment in the grand timeline of the universe, but the impact of Atlas, as brief as it may be, will resonate for years to come, sparking questions, scientific curiosity and exploration that will stretch far beyond the confines of our own solar system. Atlas is not just another comet, it's a messenger from another star system, a fragment of a distant world that has traveled for billions of years through the unknown, arriving at our doorstep just long enough to provide us with invaluable data. By studying this interstellar object, we've gained insights into the dynamics of space, the formation of cosmic bodies, and the nature of interstellar travel. But perhaps more importantly, Atlas serves as a reminder of just how much there is left to discover about the universe and our place within it. What Atlas shows us, above all, is that we are not alone in the universe. While our solar system may feel like the center of the universe, objects like Atlas remind us that we are part of a much larger, interconnected cosmos. The universe is teeming with objects, stars, and planetary systems, many of which have yet to be discovered. Interstellar objects like Atlas are not just random visitors. They are a sign that the universe is full of surprises, and that we are only just beginning to scratch the surface of what's out there. One of the most significant impacts of Atlas is that it opens the door to the study of other star systems. Until recently, we've been limited to studying our own solar system and the nearby stars that make up our stellar neighborhood. But Atlas and its predecessors, like Oumuamua and Borisov, have shown us that objects from distant star systems can wander into our own, giving us a rare and invaluable opportunity to study them up close. The discovery of Atlas suggests that there may be many more interstellar visitors out there waiting to be discovered. As technology improves, astronomers will be able to track and observe these objects with greater precision, giving us a deeper understanding of the universe's vastness. The study of Atlas is also opening up new avenues of research in space exploration. As we look toward the future, the possibility of interstellar exploration seems less like science fiction and more like a tangible goal. While we are still far from sending spacecraft to other star systems, studying objects like Atlas helps us understand the challenges and opportunities of interstellar travel. By examining the trajectories and compositions of interstellar objects, we can refine our models for future space missions, possibly even designing spacecraft that could one day travel beyond the solar system. Perhaps most exciting of all, Atlas could help inform the search for extraterrestrial life. The study of interstellar objects provides us with a glimpse into the conditions of other star systems, potentially revealing whether planets and moons in those systems could harbor life. By understanding the chemical makeup of Atlas, astronomers might discover new compounds and molecules that could be found in other star systems, ones that could support life. Atlas's long journey across the cosmos could hold the key to answering one of humanity's oldest questions: are we alone in the universe? As we continue to study the characteristics of Atlas, its size, composition, and behavior, we are also learning more about the broader forces at work in the universe. The fact that Atlas has survived for billions of years, traveling across interstellar space, is a testament to the durability of some cosmic objects. Its ability to maintain its structure and integrity despite being exposed to cosmic radiation and other hazards over eons speaks to the stability of certain objects in space, which could help astronomers refine their understanding of the life cycle of comets and other celestial bodies. What's more, Atlas is forcing scientists to reconsider how we think about space and time. It's a reminder that the universe is not static. Objects are constantly moving, drifting, and changing. The fact that Atlas has traveled from another star system to ours shows just how dynamic the cosmos is. It reinforces the idea that the universe is in constant motion, and that the objects we observe today may have traveled millions of years to get to us. The study of Atlas opens up new questions about the origin of these objects, how they travel across space, and what they can tell us about the nature of time itself. But while Atlas's journey may be one way, its legacy is far from over. The data we've gathered from studying Atlas will inform future research, not just in the study of interstellar objects, but in the fields of astrophysics, planetary science, and even space exploration. It will continue to shape the way we think about space and our place in it, inspiring future generations to look beyond the stars we can see and explore the vast uncharted territories of the universe. And just as Atlas's passage has captured the imagination of scientists and space enthusiasts alike, it serves as a reminder of the importance of exploration and curiosity. The universe is vast, full of unknowns, and Atlas has given us just a glimpse of what lies beyond our solar system. But there's so much more out there to discover. Objects like Atlas remind us that the universe is full of mysteries waiting to be unlocked, and that the journey of discovery is far from over. The legacy of Atlas is one of curiosity, exploration, and possibility. It has expanded our understanding of the universe and shown us that we are not isolated in our solar system. We are connected to the cosmos in ways we're only beginning to understand. As we look ahead to the future, we will continue to explore the stars, track interstellar visitors, and search for answers to the questions that Atlas has raised. Its brief visit may have ended, but the journey it has started is only just beginning.